So we're here at the Met Office Cardington site to validate a method to calculate the release or flux rate of methane and CO2 gas using drones. So we're going to do our first test flight with one of the fixed-wing drones today, which Chris is holding up here. Where we're just going to make sure that we've got our flight plans correct. The goal of the overall project is to see if we can calculate the flux of methane and CO2 gas that's emitted from a known source. So it's going to be a sort of a blind exercise. We're not going to know the release rate of the gas. The National Physical Lab are working with us to release the gas at a rate that we won't be told in advance. And using the measurements we'll get with the drones, we've got to see if we can observe that release rate downwind, way downwind, see if we can recalculate what that flux release rate is. And later we'll compare our results with, well, what they will then tell us in the secret flux release rate, and we'll see if we've got it right.
This is the NPL controlled release facility. This allows us to simulate a range of emission environments. So what you can do is set out 4 points of release, and so this allows us to release, in this case, carbon dioxide and methane to atmosphere to replicate a landfill scenario, so that UAVs can then test their monitoring techniques against it. So you can release gas at traceable rates, and this covers small to medium-sized releases as would be found in agricultural or industrial sites.
So there's going to be two different techniques. We've got a fixed wing, it's going to be sort of flying around in a sort of spiral helix pattern, and ours is going to be sort of on the ground with a very long inlet tube going up to it, bringing the gas back down to a sensor, or the pipe will have an airflow through, bringing the gas down to a sensor to be able to measure the concentration of CO2 and methane, hopefully in and out of the plume.
Well, the main purpose of this project is to measure plumes as they go across from the release point. So we need to know where the wind's coming from. That's quite important. So we also need to know how strong the wind is, because if the wind's not strong enough, then the plume will take quite a long time. But if the wind's really strong, the plume will be really quick to pass through the drone. And also today we've had a big problem with visibility. We've had a lot of fog this morning, so we can't fly in fog because if we can't see the drone, then it doesn't work very well. So we're hoping that the weather's going to clear up this afternoon, and we're going to have nice clear weather and be able to fly. So fingers crossed.
Well, we've got lovely weather today. Is that good or bad for drones?
Yeah, this is good in one way because we've got no rain and we've got good visibility. It's bad because we've got the sun a little bit low on the horizon, so when the drone's sort of flying near to the sun, it causes us, a bit of problem. That's why we're wearing sunglasses today. It's better when the sun isn't really too low on the horizon. And we've got really slack winds. So that means that any gas that would be released that we want to measure is sort of not going to flow very quickly, and it's subject to turbulence over smaller length scales downwind. That means that it's a little bit harder to map the plume because it will dilute and disperse much more slowly than it would with a faster wind. But I think on balance we'd rather have weather like this than it to be too windy and the rain that goes with it.
Today and the rest of this week is carbon dioxide and methane, although the gas we'll actually be releasing is pipeline natural gas, so that's 92 to 96% by volume methane. So on the left here you've got 3 cryogenic tanks of carbon dioxide, and so that has a vapour output on. What we're doing that then is feeding it into our home-built gas blending and flow control system. So that's thermal mass flow control based, and what we do then is feed it down, so you can use up to 4 of these 70-75 metre lines out to the emission points. So what we've got here is 4 release nodes, and these are specially chosen such that we release gas, but the release to atmosphere is diffuse, so the exit velocity is relatively low. Because we're wanting to replicate landfill emissions in this case, this will allow us to kind of replicate the slow emission of gas to atmospheres. In the case with a landfill, for example, methane is percolating up through whatever material is there in the top layer.
So how much gas will you be emitting?
Oh, so for this particular experiment, we were emitting both methane and CO2 at mass equivalent rates, and that will be typically between 0 and 15 grams per second.
So how much between 0 and 15 exactly will you be emitting?
Oh, that's a secret. That's a secret. So the whole point of this is to do a blind test.
So you can't tell me?
So I won't be telling you until you've submitted me some values.
So this is our temporary UAV lab at Met Office Cardington. So we're getting set up today for a quick test flight before we do anything dangerous like releasing gases tomorrow. So we're just testing the kit now and getting some flight plans ready.
So what are you going to be working on today?
Today we're going to test the greenhouse gas analyzer to make sure the data that's coming through that are okay and it hasn't got damaged in transit. We'll have a look at the data compared with the instrument that's going to fly tomorrow to calibrate it. And we're going to do a test flight with the fixed-wing drone outside in this beautiful weather we've been lucky to get today, just to make sure that the flight plans we've got programmed into the autopilot all work. We're doing a briefing now to try and work out what sort of flight plans we're going to do. This is the Explorer fixed-wing drone that's going to fly the CO2 measuring instrument. But we've got to work out where we can fly, and that involves looking at some GPS maps and any obstructions in the area, and then programming that into the autopilot.
So this is our S900 drone. It's a 6-motor drone. You see the motors attached to the end of these arms here. The motors, they all spin. One will spin clockwise and then the next one will spin anti-clockwise. And the idea with this is that a lot of this is done by the onboard controlling. So we tell it we want to go up or down or left or right, and then the onboard processor then determines the speed of the different blades and which ones to do more or less to actually tell it to do what we want it to do. A lot of the flying is done by the process. If we turn that into manual mode, there's a very good chance it would probably just crash and burn without all the processing. We've got several other things on here. We've got compass on the top, we've got cameras, GPSing to help us hold our position, and log as well down on the ground station.
So the tripod, we have a small system that transmits the data back from the drone, or at least the pictures and battery voltages and things like that. So we can see on this screen what's happening, and then we've got the controller, which we can control the drone. So we're just setting that up, and then we'll get flying.
Well, we've got 140 metres or 150 metres of PFA tubing, very, very inert tubing that's on a drum, and it is not very easy to get on and off. So I'm just trying to make our lives a little bit easier by making a sort of temporary spool to hold the spool on.
So how many drones are going to be flying today?
Just two.
Two. So which one are you working on?
I'm working on the fixed wing, which is not in this room at the moment, but it's a 2 metre wingspan fixed wing, so I'm sure you'll see that when we fly that tomorrow.
So what we're doing now is we're programming the autopilot for the mission. We've got it connected by wire to the aircraft. We're moving the location appropriately to Cardington. Do we have the right one, Chris? And so what we do is we confirm on the computer by using Google Maps that our waypoints are located approximately where we need them to be. So it's just a visual check. We'll do the flight plan, we'll upload it, we'll check with the aircraft that it's all working, and then we can take it out to the flight line.
So why are you wearing the green vest and you're in the orange one?
So completely arbitrary, but we have chosen orange to be the pilot color, so that from a distance you can identify quickly who is flying the drone. And you can also spot the spotter who's going to be wearing the yellow base. So if you have any questions or any concerns regarding the flying activity, the idea is you go to the person wearing yellow and you talk to them, and then they filter down the message or the comment to the pilot.
So if you're managing the project, why aren't you wearing the orange drones and the orange jacket and flying the drones yourself?
Because I can't fly the drones, and I'm not touching them. Every time I touch them, I crash them. So I just don't pilot these things. I just watch and listen. So yeah, I'm Chris's eyes and ears on the ground.
Army. Black Sword team, Synthetic Explorer is going to launch imminently. Confirm. Bravo armed. Yeah.
Okay. Sense check. Yep. Catapult is unsafe. Yep.
Okay, so I'm going to start the throttle.
Yep.
5, 4, 3, 2, 1, go.
What happened there?
It wasn't hit left. It is still flying as beautifully as it was before. Okay, so at the moment these guys are doing a flight risk assessment. They have both locations, so there's new risk associated with the flight. So at the moment they're just looking at all of the obstacles that might be on the way of their operation, just to make them aware of their surroundings. And after that we're going to be talking to each other about the areas where we are going to be flying the fixed-wing aircraft and the areas where they're going to be flying the multicopter, and make sure that there is no possibility for any kind of collision.
So what's all this health and safety stuff for? Why have you got a fire extinguisher and a first aid kit and a fire blanket?
Okay, so the drone uses LiPo batteries, which have a very high capacity, but at the same time they've also got a reputation of being a bit on the dangerous side if you mistreat them. They can get very hot, and if they are overcharged, overused, they will potentially explode and quite catastrophically as well. So we've got the fire extinguisher, which is I think a dry powder one, and we also have a fire blanket as well, just in case there was a problem with the drone, and then obviously first aid kit as well on site in case we have injuries. One of the big common ones would be the blades. They're made of carbon fibre, they're very, very sharp as well, so it's easy enough to, if you're not careful, to catch yourself on those.
Yes, and I can also see you're a good distance away from the drone, which is over there.
Yeah, it's all about the safety on the site as well. You have to make sure you've got a good landing area, be well away from that, and then people, if they're going to be around, they have to be near you at the time, rather than just wandering over. If someone started coming over towards us whilst we're flying, if we didn't know who it was, we'd probably land for safety reasons.
Yeah, taking off is always a critical point, because the airframe's got to leave the ground horizontally, because if it gets a bit of a kick on takeoff it can tilt. So it's always one of the most dangerous bits, like any flight, takeoff and landing, one of the most critical parts. And that is a perfect landing. We've got probably 20 different measurements of wind speed and direction on this field, and they're very useful to us as well. But as we're doing an experiment that's trying to map the spatial extent of a plume from a point source, you know, smoke flare is a really great way of gauging, you know, the wind speed and the wind direction, and a visual representation that can be any better of how the plume might disperse as we go downwind, and we can make the flight plans for the drones to make sure that we get fully across what we expect to be the plume. So we're going to set off one of these smoke flares now, and we'll see what happens. So the wind's picked up a bit since this morning, so I suspect it's not going to spread out as much as it would have done this morning. So there we go. Can you see from down there, Paul? A little bit. That has turned due northerly. That is a strong northerly.
Well, we drink tea because tea is quite an important part of the instrument scientist's role. It turns out some instruments don't actually run without tea, it works especially well when poured directly on the instruments.